Hello dear students. In this video, we will be learning how to create a stack using linked list. Stack as the data structure, it is also called as last in first out data structure. Basically, stack is meant for storing data. If somebody asks you what is stack, you simply tell stack stores data. Finished. Stack stores data. But stack stores data in last in first out manner. What that means is whatever we store last in the stack is always removed first from the stack. As an example, you just imagine that we have a bucket and we have added some objects in the bucket. And let's say we are asked to remove some object from the bucket, and there is no room such that you can put your hand in the bucket and remove the lowest object. Then you have to remove the topmost object first. Now just see, this was the last object which went in the bucket, but this was the object which came out first. If you are asked to again remove an object, you will obviously remove this object which I am striking out, which is now the last object that was inserted. Stack actually is an inherent part of our life nowadays because on our cell phone, whenever we see any SMS, or rather when we go to SMS window, we will always see the last SMS received on the top of the list, because that's the stack, because the topmost SMS is of the most importance to us. Another example is when you go to your mailbox, what you see is the mails always get stacked on top of each other. So the last mail which has come in your mailbox will be always shown first on the top of the list. So stack is very important in that way, and we see stack everywhere always in computer science and in real life also. Now there are two ways to create this stack data structure. One of the methods is by using linked list. Now in our earlier chapters we have learned what is linked list and how do you create a singly linked list. So basically, if you are asked to create a stack data structure, you simply have to write a program to create a singly linked list. Now, remember that in singly linked list, every node stores data and only one pointer. That's why singly. And that pointer points to another node of the same linked list. Now, following is a stack which I have shown. This is the stack which I have shown, which is stack of integers. Now, why it is stack of integers is because there are three nodes in this. Now, this is a node, this is another node, and this is third node. Now, in these three nodes, we have data as integer. You can see 30, 20, 10. And besides data, we have a pointer called next. Now, as it is a pointer, pointer always points or stores address of another node. Similarly, this next is storing address or points to another node. Now, this next in the node which stores 10 does not have any other node to point to. So, this next pointer is null, and null means nothing. This pointer will not store anybody's address. The diagram that you are watching, actually, if you are asked on one fine day, what is this diagram? You will say, come on, this is singly linked list. But further, you can improve if you say that this is a stack. This is also a stack. Agreed, it is singly linked list, but it is also a stack. Now, actually, what has happened, that operator, while running this program, which created this linked list as a whole, while creating this linked list, operator actually entered 10 first, and then he or she inserted 20, and finally the operator entered 30. So 30 actually was the last node inserted. Please try to understand. But the stack says that if 10 was inserted in the bucket first, then 20, and then 30, then 30 should be the topmost, or 30 should be removed first. So there is a special pointer called top, also called as header pointer. Okay, just a name given. and top will always point to the latest node that you have inserted. Now this node has a pointer called next, and next will point to the 20 inserted. Now 20, this node 20 will have again a pointer called next, and this 20 will point to the previous node, that is 10, which stores next. And this next cannot point anywhere, so this will be null. Observe that's the diagram that has been exactly drawn. What if you are asked to add one more value 40 in the stack? Now come on, 40 is the latest value that you are adding, isn't it? So this 40, which will be stored in the node, should be pointed by top. Now this has become the topmost node. And now this 40 is going to have next, no room here, I am writing next like this. And this next will point to the node which stores 30. But check this top. Top is now pointing to 40 and 40's next is pointing to 30. This is stack. So the last value that you have inserted has become the first value, that is topmost value. So in general, I have written here the definition as you can see, and in one sentence, I have written ith node of the stack. If you call this as ith node of the stack refers to I minus one node. It is referring to I minus one node, isn't it? And the header pointer top always points to yes, last node of the stack. 40 was actually the last value inserted and top refers at that node. So that is what is stack, last in first out data structure, and it can be created by using singly linked list. Now in the next video, we will be learning how to write a program for implementing stack, and I'll be explaining how to create a stack using linked list. In the later videos, we will also see how to create a stack using array. We can create stack using simple one-dimensional array also. But from this video series onwards, we will be concentrating stack using linked list. So see you in the next video where we will start the implementation of the stack using linked list. Thank you very much.